Most music today is made in factories like this one. This machine is a Underwood Mammoth Beat Organ. The makers of the machine are also its operators. Every piece of music begins with a central drive shaft. An operator turns its speed dial, and the beam begins to roll. A second operator brings in the first component. On connecting to the drive shaft, a wheel pumps a pair of bellows, which in turn pump air through two valves. An air pipe is attached to the first valve, and the other end is attached to an organ pipe. Each time the bellows pumps, a note is played. A second pipe is attached to the other valve. One end of this pipe is sealed, so a reservoir balloon begins to fill with air. A second unit is wheeled in, the wind sequencer. Once our balloon is sufficiently full, the other end of the pipe is attached to the wind sequencer. The pipe plays a continuous note because the balloon reservoir keeps pressure even when the bellows take in air. Pegs are added to the wind sequencer's cams to determine at what point in the cycle the valves open. An operator chooses 4 from a selection of lead organ pipes. The smaller pipes play higher notes and the larger pipes play lower notes. When the wind sequencer is offered up to the drive shaft, it begins cycling through all the notes. Working together, our operators now produce the first piece of music for the day. For the day's second piece, alternative components must be mounted. Drums and percussion are selected for the newly introduced rhythm unit. A beater is connected for each of these different drums, with the beaters being controlled by a selection of different coloured cams. Plain cams play in 4/4 time, green cams for divisions of 5, yellow cams for 6/8, and red cams for divisions of 7. The turntable is added. The gears connect, meaning the platter will rotate once for each cycle of the drive wheel. A wheel module is added, onto which a tombola is placed. Small wooden shakers are placed inside the tombola to roll around continuously. A special beater is used to create friction on the surface of this tom-tom drum, creating a tone. The pitch of the snare drum can be altered by sucking air out of the shell. Cams can be hot swapped at any moment, replacing one rhythm with another. A quick adjustment and the new part is in time. With the new equipment in place, the next piece can begin. For the next piece, the bellows are returned to the machine. This time they're used to inflate a much larger balloon. The rhythmical cams are removed, replaced with 2 irregular circles. The drums are reconfigured, removing the sticks and adding dangling chains. As the wheels move, the chains are jangled over the cymbal. The wind sequencer is returned. It's placed in position but not connected to the drive shaft, so the operator can select notes manually. Now fully inflated, the large balloon is brought round and connected to the wind sequencer. The pegs are reconfigured so that all valves can be open at the same time. Similarly sized organ pipes create beat frequencies. The microtuning of each pipe can be altered throughout the piece. As the operator plucks the spring roller with a plectrum, the next piece can commence. It's been a long day at the music factory, but there's still time for one more piece. The bass drum beater is replaced with a harder mallet. An additional spring is attached for greater tension. A new set of rhythm cams are selected and put in place. A tambourine arm is attached to the cam unit. A melodica is placed on the air sequencer. Foghorn pipes are connected to the bellows. The drive shaft is started at high tempo, and the final piece commences. Once the music ends, it is checked by the operators for quality, before being distributed on audio cassette, or sometimes played live in front of an audience. To find out more about the Mammoth Beat Organ, just visit your local music factory.